Let's see here. Do some experiments. Let's get going. All right, I got 2 flasks on here. Let's get a little bit more brightness back there, just so it looks a little prettier. Come on. I think that's going to capture it. Nice. Let's start messing around here. A little hydrochloric acid. A little hydrochloric acid. A little bit more. Yeah, this one on the left is unbuffered. The one on the right is, the one on the left is buffered. The one on the right is not. So you're going to see color changes when I add, now I'm going to add base over here on the right and then base over here on the left. You'll see a lot more color change on the right than you will on the left because this one's buffered. And to buffer the solution, all I do is add a effervescent cold relief tablet. This is kind of cool if I just kind of stick it in. Look at how that, the bubbles that are produced and the reaction between the sodium bicarbonate and the citric acid in the Alka-Seltzer tablet kind of makes a little bit of a double helix vortex. You can see how the bubbles get trapped in the vortex. I don't know if you can notice that. If you look at this vortex over here, it's kind of transparent, nice and smooth. And down here at the bottom, you see all those bubbles are trapped in it. That's because the vortex, just like the eye of a hurricane, is low pressure. Well, so to speak, the eye of the whirlpool or the eye of the vortex also has low pressure. And of course, that's where the gas bubbles are going to end up. Very cool. Having trouble connecting here. What the heck? A little bit over here on the left. A little bit more base. Watch what happens when I add the base over here on the left. Watch what happens to those bubbles. You see how they're disappearing? That's because the sodium hydroxide that I'm adding is chemically reacting with the carbon dioxide and transforming it into something that actually dissolves in the water. Very nice. All right, let's add some acid over here on this side. A couple drops. It's kind of fun if we get the rainbow effect going on. That's happened sometimes. Right now we got the stoplight effect going on. I'm going to chase this with a little bit of base over here. So in both flasks, I know there's a lot going on here. So let's just kind of, maybe we'll just focus here on the one on the right for a bit. Whoops. Let's just talk about what's going on over here. So in this flask over here, what I have is some universal indicator. And universal indicator is going to display a variety of colors depending upon whether the solution is acidic or basic. So here's the different colors that you could potentially see with our universal indicator. So, you know, right now, what does that look? Kind of like orange-yellow. So that means our pH of the fluid is like maybe like a 4 or a 5. Probably more like a 5, so it's slightly acidic. Let me get this light just a little bit better. Actually see what's going on here. Excuse me a sec. There we go. Yeah, so we see that the pH is about a 5. And then if I add base, sodium hydroxide base, I'm going to add 20% by weight sodium hydroxide. We add that over here, and you'll see colors that are looking kind of violet. That makes sense because as I'm adding base, the pH should go up. And that violet color that you see is from the base that I've added. You'll also notice that the material that I add tends to stay centered in the center of the vortex. That's because the center of the vortex, just like the eye of a hurricane is low pressure, the center of this vortex also is low pressure, and it kind of forms a stable flow there where the material pretty much stays. Of course, some of it gets pushed down to the bottom, and when it hits that stir bar, it gets pushed out along the sides. And when you see that, of course, the rest of the material in the flask will turn to the violet color or blue. Let's check it out here. Let's check our pH level again. So checking out our pH level, we see that's like a blue color. That's looking like a pH 9, yeah, which is quite basic. If I add just a bit more base, we should be able to get it all the way to pH 10, get that violet color. There it goes. We got a nice violet color growing in. And that's with the higher pH. All right, now I'm going to add some acid. And that should lower the pH, so we're going to add a couple drops of acid here. You can, if you look, you might be able to see that that red color is right there in the middle. And then, of course, once it hits the bottom, it gets spread out along the sides. And right now, the base is being neutralized by the acid that I've added. And it looks like the entire fluid, well, where's it going to relax? It's kind of like a yellow-green color, which is just a little bit less than neutral pH. Just a bit less. Just see if this lighting helps a little bit. I'll continue to add acid. And you can see as I continue to add acid, the pH, well, the color shifts to like an orange. Yes, that's right, K-Crow. The acid I'm using is 20% by weight hydrochloric acid. Thank you there, Agent J. Appreciate it. As I continue to add acid, you see that the color goes a lot more red than it was before. I'm trying to get the lighting right here. I think if we move to this flask over here, things will look a little bit prettier. So just bear with me a second. I'm going to move this flask out of the way. And we're going to pop this one over here. I think we're going to get the color right now. I hope so. A little bit brighter color for us. All right, let's get this rolling. I'm going to cut this one off. All right, let's get that vortex going again. Thank you there, Agent J. I appreciate that. I got a sub. That's very nice. Very nice. I do lives on the weekend, usually around this time. I'm considering it the weekend. I think I'm going to cut this light off here in the back just to see. And we're going to start adding some base. So let's start adding some base. Live chemistry. That's right, Coco Z. So I'm adding some base here to a solution of universal indicator. And just watch the magic happen, man. I mean, it's just kind of gorgeous what happens. Kind of like a mixture of science and art here, in my opinion. So the universal indicator is also known as rainbow indicator. That's because it displays all of the different colors of the rainbow depending upon pH or how acidic or basic something is. Hey there, Malignant. There it was. You see that flash? We got the flash of the rainbow. So Veldora, what's happening? Thank you there, Malignant. I appreciate that. What's happening here is in this flask, I have some universal indicator, and universal indicator is going to display a variety of colors. Let me show you what they are. It's going to display these colors depending upon whether the solution is acidic or basic. The lower the pH value, the stronger the acid, and the higher the pH, the more basic it is. And pH 7 is neutral. Yes, Martin, there is negative pH. Negative pH would be something with a that gives you an H plus concentration of greater than 1 molar. Okay, so neutral is 7. Right now it's looking like, maybe pH 5 or 6, so we're slightly acidic here. I'm going to start adding some base now, and the pH should increase. So you got sucked into the world of chemical engineering. Well, that sounds kind of interesting to me there, Cuckoo Z. I'm sure you're learning some pretty interesting stuff. Looks like our vortex is lost here. Let me try to recapture the spin here. So Veldora, you did this with litmus paper. Interesting. Another thing is there are papers out there on the on actually the flow patterns that exist in fluids with magnetic stirrers, and indeed it does show a stable flow in the center of the vortex, which makes sense. I mean, if you think about it, you're going to have a stable flow in the eye of a hurricane. Why wouldn't you have, or it's stable flow. Why wouldn't you have stable flow in the center of a vortex? Right now I'm adding acid, so you'll see a bunch of red color develop. Usually the material that I add, it initially stays in the center of the vortex. So grade 10 student in chemistry. That's very cool there, K. Crow. There it is. We got the rainbow, baby. I love it. Mostly reactors and unitary operations. Interesting. Why does the flow pattern keep changing? So Stonehenge, man, this is not an infinite bath. And so, you know, you're going to have a stable flow down to the bottom. If you look carefully down here, appreciate that, Cuckoo Z. Thank you there, agent. There's a stir bar down here. And so, like, I'm going to start adding some acid, which will, you know, change the solution to a more red color. You see, when I first add it, most of it stays in the center of the flow. But when it hits the bottom, then it gets pushed out along the sides. That's right, I'm using hydrochloric acid. Thank you there, amen. Appreciate that. We did get a pretty nice rainbow. All right, let's try adding some base. It is really looking pretty. I got the lighting just right. So we're going to add some base here. And watch what happens. I think I'm going to add a little bit more, try to catch that rainbow. Thank you there, Stonehenge man. Hey, tell me where y'all are watching from. I'm in the United States, the state of Michigan. There's your rainbow, baby. Come on, that's cool. Oh, that's beautiful. A little bit of acid. Someone from India. Wonderful. Thank you, Veldora. Ireland. Nice. Stonehenge man. That makes sense. Malaysia. Another U.S. Someone from Canada. It's really cool, man. People from all over the world. We're hanging out, doing a little bit of science experiments. Of course, I've heard of Algeria there, Cuckoo. Sorry, I apologize if I'm not saying your all's names right. I'm really sorry about that. I'm doing the best I can over here. We got the rainbow has entered the chat. The rainbow has entered the chat for sure. Yeah. Wasn't that a cool little flow pattern? You see that? That was pretty cool. That was pretty cool. From the forgotten state. Help me out, Prince. The forgotten state. What's the forgotten state? I wouldn't know what one that is. All right, chase it with a little base here. Isn't that cool, man? Look at that. It's really cool. Narnia. Delaware. Gotcha. From Delaware. That's the first state, buddy. Hey, yeah. Great idea there, Martin. Great idea. Everyone drop in the chat your favorite element. It sucks not many people post this sort of stuff and it doesn't get seen in the world of science. You're absolutely right. The world of science is a pathway to the world of the unknown. Isn't that true? And it's also a pathway, in my opinion, to beauty. I mean, I'm just setting this up and then nature does its thing. And this, to me, this is art. I think this is like art and it's really beautiful. Your favorite element's air. My favorite element is hydrogen. It's the basis of the periodic table. It's the basis of all material matter. Hey, Simon, how's it going? And yeah, that's why I like hydrogen. Would the magnetic stir plate be less efficient since it only really stirs in the middle and takes longer to stir properly? Like Kikro, I apologize. I don't understand the question. The art of science, watching rainbow in a glass. That's right, amen. It's beyond art. It's science, huh? Are we allowing radicals? Help me out, K. Crow. You're speaking in some cryptic terms that I'm not following. I'm a little slow. That's cool, man. Your science teacher would watch for hours. Let them cook, baby. Full purple power. You got it, Veldora. We're going full purple power for Veldora. I'm going to add it out here to the sides. If you'll notice, if I add the drops out to the sides, the colors change more quickly. Radicals, polyatomic ions. That's right, cooking a rainbow, huh? It does look like an aurora. Yeah, Stonehenge, man, I love it. Look at that. Science builds the world, art helps us enjoy it, and this is both. That's kind of cool. I can't make it black. This is as dark as we're going to get it here with the violet. This time I'm going to watch this. I'm going to add 3 drops, 1, 2, 3 of acid to the center of the vortex. Martin, my favorite experiment is whichever one I'm doing at the time, and that's the truth. How about you, bud? So what I'm going to do, notice I added 3 drops to the center of the vortex, and you kind of see how long it takes for the material to disperse. Thank you there, Agent J. My favorite building, my home. Okay, now I'm gonna pop this back and make it violet again. All right. So I'm adding base right now. I think I'm gonna need 3 drops to make it violet. Now you remember last time I added the acid to the center of the vortex. So a question, if you gently heat the solution, will that affect the production of colors? I think it will, but I'm not sure we're going to be able to see it. Martin, you should check out my channel. I do a few of those types of experiments. I like doing that one too, K-Crow. Okay, here we go. I'm going to add acid, but now instead of adding it to the center of the vortex, watch, I'm going to add it out here to the side. So 1, 2, 3 drops. And you'll notice just how much more quickly the color change occurs in this particular case. Really goes rapidly. And that's because when you add stuff to the center, like this, I'm going to add base to the center. It kind of stays in the center of the flow. There's 3 drops. And the color changes when I add it to the center. They take a lot longer to develop. That's right there, Veldora. Base for purple, acid for base. That's correct. Very true. Yeah, let's show that. Good idea there, Agent. So we're going to show the scale for acid and base again. You get the camera going, or the light going. So you can see we're at pH 10, which is quite basic. And as I add base, it's going to tend to drift this direction. As I add acid, that'll neutralize the base and send us back in this direction. And that's basically the gist of the experiment. Thank you there, James. So let's start adding some, I'll just put that down there just for a bit. I don't want to leave it there too long because it obscures the view. All right, let's add some acid, and you can watch what's going to happen. The acid I'm adding is hydrochloric acid. It's the same acid that's in your stomach. It just happens to be like, 1,000 times more concentrated. So that's 6 drops of the acid. You'll notice immediately in the center of the vortex, it turns red, which would be expected. And I'm going to take this out so you can watch the magic. Come on, that's cool. Just look at all that crap happening in there, man. That's just really beautiful. Thank you there, James. I appreciate the sub. Make it full red power says, Veldora, you got it. Martin, I think I'm going to start doing lives on the weekend. So it'll be Friday, Saturday, Sunday, right around this time. I'm not going to do them every day, but, be looking either Friday or Saturday or Sunday. James Williams. James Williams is in the house. You got it, bud. All right, so we got it full red. You're welcome there, Veldora. And now we're going to add a little bit of base to send it back in the other direction. We ready to go? Here we go. James, you got a channel? Try mixing 10, 3, and 7, see what you get. You got it. Let's do that. We're going to do that. It's going to be a little tricky, but I think we may be able to pull it off. So how are we going to do this? This is how. This is how. Looks like fruit juice. Indeed, it does. I'm going to get a different glass over here. All right. We got a different glass over here on the side. All right. Somebody said they want to see a mix of 10, 3, and 7. So in this flask over here, we're going to put some water. Hey, James, I thought I already did shout you out there, bud. You got a channel? Check out James Williams' channel. Sato, you would not want to drink this stuff because one of the dyes in the indicator is a laxative. That might make you stop watching the short kind of quick. So in this one, I'm going to go ahead and add some universal indicator. And we got to make this pH 10. So to do that, I'm going to add a drop of base, of course, right? Let's check it out so we know what we're doing here. So I'm going to add base to get it to pH 10 because the Batman add peroxide and acetone. Not happening here. Okay, so we're going for pH 10, which means I want to see this turn purple. 1 drop. There's our violet. All right, so we got this. I'll set this to the side. Then we'll get another flask out. Where the heck's my flasks? I just pull, here they are. All right, so we'll get this one out. It does, it is yellow. So Veldora has noted that my universal indicator looks yellow. It's actually green. Let's talk about what's going on here. So here we go. In goes the water. Okay, now I'm going to drop that base. Now I'm going to add the universal indicator. Now check this out. Notice the universal indicator is green, which is neutral, but when I add it to the water, it changes yellow. What the heck is going on there, right? What the heck? I thought water was neutral. Here, watch this, but it's not. Sorry about that. Look at this. The water is yellow, which is a pH of 6. I thought water was neutral. Well, the deal there is that water exposed to the atmosphere is going to have carbon dioxide from the atmosphere dissolve in it. And when carbon dioxide gets into water, it makes the water slightly acidic. Okay? So that's why water, it's actually distilled water that I'm using, is going to have a pH that's slightly less than 7. So we got to get this to pH 7. So to do this, I'm going to add a drop of base, and then I'm going to add a drop of acid. Batman, you don't want to drink this. Let's swirl that around. Looks like I have oh man, look at that. There was a bunch of crap going on in that. I think there we go. We got a green. All right. So again, the question was, that's correct. CO2 in water makes it acidic, Veldora. That's correct. So I have a pH of 7. Here's my pH of 10. And now we got to make a pH of 3 because that was the request, to mix pH 3, pH 7, and pH 10. So we've made 7 and we've made 10. Now we've got to go with our pH 3. So in it goes. We got a little more water. My distilled water. We'll add the neutral universal indicator. There it is. It's green. Add it to the water. That's going to turn yellow because of the carbon dioxide that's dissolved in yellow. Excuse me, in water. And now to make this pH 3, I'm going to add 1 drop of, thank you there, Agent J, 1 drop of acid. And that's going to get us to our red color. So let's recap here what we're doing. Speaking of recap, where's my cap to my universal indicator? All right, I'm going to take this off for a second. And we're going to see what happens. So the request was take pH 3, which is this. Take pH 7, which is green. And take pH 10, which is violet. And mix them all and see what happens. So that's right, Stonehenge Man. Tap water is going to be slightly acidic with an asterisk there, Stonehenge Man, because it's going to depend on what minerals are going to be dissolved in your tap water. So there are some minerals that can be dissolved in water that is going to make it slightly basic. So that can occur as well. But if the water is, pretty much pure, getting anything pure is a challenge. But if you get, pure water, so to speak, and it's exposed to the atmosphere, it'll be acidic. That's great guess, Veldora. Veldora's guessing when we mix all these together, it'll turn green. That's my guess, too. But I'm curious as to what the rest of you think when we mix all these together into a single flask. I mean, pH 7 makes the most sense. However, there might be an excess of base, like a little more base in here than there is acid in here. And if there's more base, we'll probably have a slightly basic color, so maybe somewhere 8 or 9. And if there happens to be a slight excess of acid, we may see like pH 4, 5, or 6. Let's check it out. Let's see what happens. Where's my other flask? Here, we can use this one. This nice, pretty vase. Okay. All right. So we're going to stick this in the middle. I'm going to pour in the green first. There it goes. And then I'll pour in the violet and the red at the same time. Powerpuff Girls. That's hilarious. Here we go. In they go. Let's see what happens. My guess it'll stay green. It looks like we got an excess of acid. Definitely had an excess of acid. That's why we're seeing the red color. So I was off. Most of us were off. Hey, let's see what the flow looks like in this. And that's because we have an excess of acid in the material. Yep. All right, let's add a little more water to this and fiddle around and see what kind of flow we get in this flask. Who knows, huh? Who knows what we're going to see? Where's the stir bar? Where's my stir bars? There they are. We'll drop this in. Red winds indeed. Red Sea. All right. See what kind of flow pattern we get here. Okay. Let's just see. We'll add some base. I'll just turn this down just a bit. Let's add a couple drops of base and see what happens. 1, 2. 1 might be all we need. Look at that. Come on, that's gorgeous. Wow, that was pretty. That was pretty. Let's add a drop of acid. The acid I'm using is hydrochloric acid. That's the same acid that's in your stomach, except it's like 100 to 1,000 times more concentrated. We did get the rainbow, Agent J. We did get the rainbow. A little bit of base. So, thank you there, Agent J. Yep. Just keep running it back and forth, huh? It's pretty. It's a little more turbulent in this curved flask. So Omar, what's spinning at the bottom? Thank you there, James. What's spinning at the bottom? What this vase is on is a stir plate. So you can see here it says magnetic stirrer. And inside that square plate is, think of it like a fan, but the blades of the fan are magnetic. All right? And then what we chemists do, is we put inside our flask, we put a little, where is it? I'll answer that in a second there, Martin. We put a little stir bar in. Here, let me show you. Little stir bar. So this is just a plastic-coated magnet. And so, of course, as the fan blade spins, the magnetic fan blade, it causes that little magnet to spin. And what's nice about that is that, it stirs the mixture and it leaves my hands free to be able to do experiments. So did you need sulfuric acid to make copper sulfate? Well, I suppose if you drop a piece of copper into some sulfuric acid, that's going to dissolve the copper and ultimately make some copper sulfate. Is there a way to keep it changing? I'm not real sure. Thank you there, Omar. I'm not real sure what you mean by that. How to keep it changing. I have to continually add either acid or base to make it change. It is pretty. Very pretty. I just like this experiment. It's a lot of fun to do. I think we could use a bit more color. Just a bit. Because I don't know if you noticed, but the colors on the acid end are just a little bit weak. To keep it from staying on the side of base and acid. Yes, we could make a buffer. I think that's what you mean. So if we make a buffer, that's going to resist changes in pH. Oh, for it to change on its own, you mean like an oscillating chemical reaction. Um, those are possible. I have a video out on that on my channel if you want to check it out. I don't really go into detail about what's really happening in those because they're particularly difficult to describe. Oscillating chemical reactions are. Really, in order to understand them, you have to know a little bit about differential equations. Just a bit. It helps to know. I mean, you can understand them, but to really get down to the guts of what's going on, it helps to know a little bit of calculus, just a bit. But you can gain some intuition as well without knowing the mathematics. It is a pretty blue, Agent J. I'm almost hesitant to change it, but we got to keep... Yeah, I am, Sato. I am a professor. I'm a professor of chemistry. It is an ocean blue, but we're going to add some acid. 2 drops. How about you, Sato? Are you a student? Are you a professor? Are you a doctor? What do you do? What kinds of things do you enjoy? That's gorgeous. Really pretty color changes. Your plans for the summer is doing chemistry experiments. Indeed, I will be doing some chemistry experiments this summer. That is definitely true. Trying to get some filming done for new videos. I got one coming out tomorrow. It's on an interesting cobalt crystal. If you know your chemistry, I'm sure you're familiar with it. The cobalt crystal that I'm putting the video out on, it's cobalt chloride hexahydrate. Martin has some trouble understanding valency. I can try to explain it there, Martin. So yeah, it's just it changes to red and blue. Agent J, yes, I have had something blow up. And in fact, I do some experiments where I do that on purpose. Is that the same acid that caused gastric and stomach? Yes, amen. It is the same acid that's in your stomach. The difference is, though, bud, you got to understand that this little container that I'm using for the acid has more acid than your entire stomach. So this probably has the acid that's contained in maybe 100 to 1,000 stomachs. All right? So this is very highly concentrated, what I'm using. You're a student. Chemistry is your favorite, but it can be. It absolutely can be confusing. And, it's like any other human endeavor. Learning how to do chemistry, learning how to ride a bike, learning how to play a sport, play an instrument, be an actor or actress. It just takes a lot of practice. And the more you practice it, the better you get at it. It's just like any other thing that we do as humans do. How you doing there, Caleb? Good to hear you. Good to see you. It is indeed a small world. So the HCl in the stomach, great question, Valdora. So what that would look like is actually probably about a pH of 3. So, excuse me, a pH of like 2 or 1. So this indicator at any pH below 3 is going to look red. So if we mix that stuff with some stomach acid, as long as there wasn't any other gunk in there, it would look red. Oh, you like the U of M experiment, huh? That was fun. That was fun to do. Yeah, put that one out today. Yeah, be looking tomorrow about 8 o'clock. I got a short form video coming out on the on a cobalt crystal that switches between blue and violet. Excuse me, blue and red. Hey, Caleb, I actually have looked this up. If you look in the literature, you'll see that on average, and on fasting, the human stomach has a pH of about 1.5. Now, I know there's a lot. Thanks, Caleb. There's a lot of variation in humans, but indeed, the values I've been able to find in the literature are pH of 1.5. All right, Stonehenge man. Appreciate it. Appreciate you hanging out, and thanks for representing Ireland. Agent J, the amount of dye that is required, the concentration of dye that is required to get these particular colors is quite low. However, I just save the mixture because this is reusable. Just cover it up, and then I just use it again. I mean, all it is it's dyes and water, and then of course, I can show you the chemical reaction that's happening. Where's my sheet of paper that has that on it? If I can find it somewhere. Where is it here? Well, maybe I can't find it. Well, the reaction is just a reaction between. Here it is. There it is. Here's the chemical reaction. The sodium hydroxide reacts with hydrochloric acid, and it makes water and salt. It makes salt water. So I just make sure it's neutral. It makes a pH of 7. Then I got salt water with a little bit of dye. Cover it up and save it, and use it again for future experiments. Thank you there, Desert Tortoise. Appreciate that. We're just hanging out, doing some science. I'm talking to folks, and when people drop in the chat a couple of your favorite channels, a couple of your favorite experiments, maybe some experiments you'd like to see me try, and to try to, put my own twist on it, maybe get it on my channel. Any ideas, pop it in there. Acid and neutral would probably make yellow. Why don't I make it change different colors by themselves? James, you want to check out my oscillating chemical reaction video. All right, Omar wants to see it go faster. Here we go. Right here, you can see me down there at the bottom, right here. I'm turning up the speed. It is likely that I'm not going to be able to get it to go full speed. Nice, James. Thanks. That experiment, James, is not one that I'd want to do in my basement. So I'd have to... Up there it goes. See, if I get it going too fast, it knocks the stir bar out of orbit. Thank you there, James. Yes, but that's not an experiment that I'm going to do in my basement. That's not something I want to have hanging out. This stuff is just salt water and dye, so it doesn't bother me. Thanks, bud. Hello there, Fun. How you doing, man? Or pal, or whatever. Have I made manganese? I have, Martin. I've made manganese heptoxide. So you're going to want to look at, I think the reaction is, now I didn't isolate it, but I have made it. So, I take, we took a sulfuric acid. So Desert Tortoise says, chemistry in high school and college, main emphasis was always on theory versus lab. I wish you would make a video suggesting more practical ways to learn chemistry. Hey, Desert, I encourage you to maybe check out my channel and see that while I indeed do try to talk about why chemical changes are happening, there is an enormous amount of experimentation on my channel. Thanks, James. Very cool. And now I lost my train of thought. Somebody asked something here. Oh, manganese heptoxide. So, yeah, manganese heptoxide. I took some sulfuric acid, and you add a little bit of ethanol on top of that. The ethanol floats on top. And then you add in crystals of potassium permanganate, and indeed you'll see the green manganese heptoxide form. Hey, Medical May. I do some live. So Medical, give me some initials in the chat so I know which particular institution we probably met at. I'm adding drops of base right now, because I've taught at a couple different institutions. If you feel comfortable. If not, I understand. Put a couple drops of acid. Look at that. Let's keep going here, back and forth. Water and lithium metal is fun. It is. Check out my channel. I got some videos on that. Oh, nice. Nice. 1100, 1040, or 1140. And medical, I want to know. So you, I imagine you're studying your pre-med, 1100. Omar, okay. Oh, yeah, I love it, Sato. Nice, Omar. Thanks for letting me know. 1140, nice. Yes, Rim. Rim wants to know what's going on. So let's talk about that. So what I have in this flask is some universal indicator. It's also known as rainbow indicator. And it's a mixture of dyes, that display these different colors at different pH values. Now, pH just tells you how acidic or basic something is. And the way the scale works, nice, Medical and Omar, the way the scale works is a pH of 7 is neutral, like what we've got in the flask now. And then if I add acid, just a little bit, the pH will drop and we'll see like a yellow color. And as the mixture gets more acidic, if I add more acid, it'll go all the way down to red. That's the lowest pH value. That's the most acidic we'll be able to see. If I add base, then the acid will get neutralized and that'll pull us way back up to pH 7. If I add an excess of base, then that's going to pull us into pH 8, 9, or if there's a bunch, we'll get to pH 10. Now, we'll start doing that. So I'm going to add some base now. And what you'll notice, there's a lot going on here. You'll notice as I immediately drop it in there, it turns to a violet color, and I start adding some acid, and you see a bunch of different colors happen at once. What's going on there? Why do we see so many different colors? Well, that's because, you're welcome, Rim. That's because chemical reactions take time. And it also takes time for the mixture to homogenize. And so when you see a variety of colors, what you're seeing is a variety of pH values in the fluid all at the same time. And when the mixture, like now, finally homogenizes, then it'll display the pH after everything has reacted. So it looks like the acid and base have been neutralized at this point because I'm at a pH of 7, which is, remember, that's our green. Let's add a little bit of acid. There goes the acid. I saw I'm not adding any uranium. That's right, Medical. Doing some buffers. You had enough with 1100, huh, Omar? So there was a question out there, what's the acid in battery acid? Generally speaking, sulfuric acid is the acid that people generally associate with battery acid. Gen Chem 2 is kind of fun, Omar. I mean, it really brings everything together. But I understand. Omar, I imagine you're an engineer, would be my guess. I think I know who you are, but you have to forgive me. There's quite a few of you. Add a little drop of, what is that? That's acid. Let's add a drop of base here. Oh, look at that beautiful, beautiful color. And we might get the rainbow, baby. Come on, man. We want the rainbow. Yep. I know who you are, Omar. Nice to have you along. Thank you there, Medical. I had a good time in it. I love teaching chemistry, man. It's what I do in my free time. I got to get a life. My wife's out doing yoga right now, so that's why I'm in here doing this. Hey, fun. I don't have any lithium metal with me, so that's not going to happen. I love electrochemistry. Man, do I love it. Love me some electrochem. I'm trying to get the rainbow here. Chemistry is life. Turn it down just a bit. If I turn the speed down, then the colors persist a little longer. Look at that gorgeous flow. Man, is that just beautiful. Pies, what is in my solution is simply water. So it's an aqueous solution. And then I've added universal indicator. And if you want to know what universal indicator is, actually a mixture of 4 different acid-base indicators. And those acid-base indicators are thymol blue, methyl red, bromothymol blue, and phenolphthalein. Kimberly on asks, so the indicator is not binding to the chemicals. What about it is causing the color? Well, how about the history of chemistry for videos? Are not your style. You know, I do have a, man, there's a lot of questions coming through, so bear with me. I do have a video out on how chemistry connects to the Titanic, and I was thinking about one to talk about De Hevsey. There's a very interesting story about the chemist De Hevsey um, that I want to do some stuff with. Andrew, I do not exchange notes with Nile Red. Love his channel, love his work. I tend to be a lot more careful. I have not made, well, bromide I've made, but not bromine, Martin. So actually I have made bromine. I have made bromine just a little bit. Pies, I do have potassium iodide and iodine and starch, just not with me. So I do these experiments at home because it's just making salt water, and it's just a little bit of indicator dye in there, so I can just save the solution on the shelf. So the question was, this is kind of interesting. So this is going to be a little difficult, but see if you can hang with me. Okay, we're going to talk about how the colors change in this reaction, and we're just gonna simplify it for a bit. We're going to imagine there's just one indicator in there, and that indicator is phenolphthalein. So that's this one here. We're going to talk about phenolphthalein. All right. So let me just show you this. Phenolphthalein is actually colorless at all these pHs, at neutral and to pH 8. And then at pH 9 and above, it gets a pink color. Can I use the indicator to just... Oh, I don't have any salts with me, medical. Yes, fun. I have tried Mel Science products. Okay, so how does the color change? So we're going to imagine there's just one dye in here. And that, you know what? I do have some phenolphthalein if you want to see it. We can do experiments with that. But imagine there's one dye. And what happens is these indicator dyes, they bind protons. The indicator dye will bind protons. And when it binds a proton, the proton chemically sticks. Colloquially speaking, it chemically binds to the indicator molecule. And when phenolphthalein has that proton bound to it, there's actually a ring in the structure, which means there's a place where a bunch of carbon atoms make a circle and they bind back to themselves. And when the phenolphthalein molecule does that, its structure is such that it has no color. Now, what happens when you add bases are proton acceptors. And so what happens is when you add the base, like I did just now, the base will accept the protons, in other words, steal it from the phenolphthalein. And so the phenolphthalein gives up its bound proton, and when it gives up its bound proton, it breaks the ring structure. So the ring goes boop like that. And with that change in chemical structure comes a change in color. And that should make a lot of sense, right? That the properties of chemicals depend on their structures. And so it's kind of interesting to recognize that, as these indicator molecules, they're special. God, that's beautiful. They're special because all they need to do is either grab onto a proton or release a proton. And in so doing, when they grab onto a proton, changes its structure, changes its color. And there's a wide variety of these indicator molecules that show a wide variety of color changes and a wide variety of structural changes. And when you mix them all together in a clever way, you can get universal indicator like this. Is potassium iodide toxic? Well, I'm gonna defer to, I forget the Greek philosopher who said this, that everything is poisonous and nothing is poisonous. It's the dose that makes the poison. So potassium iodide in small amounts is actually good for the body. Iodide is a mineral that's needed by human beings. But of course, if you have too much of it, thank you, Desert Tortoise. Drop in the chat. Paracelsus. I don't think you spelled it correctly, but that's exactly who it is who said this. Yep. And so even water, for example, even water is toxic if you drink enough too quickly. If the dose is too high, and people indeed have died by drinking too much water too quickly. Over here in the U.S., people sometimes do some crazy challenges because, we're all about doing things bigger over here. and they were doing a challenge to see how, how fast people could drink water. I think it was on a radio show or something like that. And sure enough, a woman died from that. Probably just diluted the electrolytes in her body to a point where, her body could no longer function. It's just horrible. But yeah, I don't know if you can hear my dog barking up there. Perhaps I could do a spectrophotometry with acid-base system like you're showing. Yeah, I think so, Aldwin. Now, I don't know if I could do that at home. Do I have any vinegar to add? I do have some vinegar. It's upstairs, though. My dog's going crazy. I wonder what's happening up there. You know what? I wonder if my kid came home. Yep, my kid's home. My kid's home. It's time to end the live. My kid is home. So, thanks for hanging out with me. Hey, Jack, I'm finishing up here. I'm going to go hang out with my kid. And thanks for joining in. Had a great time with you. Be looking for these lives around this time, during the weekends. Thanks there, Kimba. I appreciate y'all hanging out there with me. And we're going to call it an evening. So long, everybody. And we'll see you, around this time, either Friday, Saturday, Sunday next week. So long, folks. Bye-bye.